Okay, so as I promised, now we're going to take a look at sample proportion and confidence intervals. So if I can squeeze this on there. There we go. All right, so sample proportions and confidence intervals. Where's my sheet? Here it is. All right, so again, you will not be given the P, the population proportion, anymore. Instead, you will find an interval that captures P. All right, so we're looking for an interval that's going to capture P with a C level of confidence, and we're going to use P hat. That's going to be our sample proportion to do this. All right. So from the sample, we're going to make some conclusions about P. We're no longer finding probability anymore. We're finding an interval that's going to capture P. All right. So the conditions that we have to meet are the same. SRS. Population has to be 10 times our sample. N times P greater than 10. N times 1 minus P greater than 10. The formula. This is one that's given to you on the formula sheet. This is one specifically for what we're doing now, which is a sample proportion. So it's C level of confidence equals P hat plus or minus Z star. It's a critical value. You're going to find that on the infinity line. And then your standard deviation for your sample proportion. That's the P hat value. Minus 1 minus the P hat over N. Okay? When you find this confidence interval, you're going to then make a conclusion. We are, at whatever C level you're talking about, whether it's 90%, 95%, confident that the true proportion is in the interval blank. You have to make this more appropriate for the question that you're answering, so the true proportion of whatever you're dealing with in the problem is in the interval. Okay? So that's what sample proportion is in terms of a confidence interval. Looking at an example that shows this or illustrates this, that'll be this example, one of the homework questions that we had to do. It talks about there are approximately 30,000 companies that are members of charitable collaborative across the entire country, a random sample of 250 of these companies, and they're talking about CEOs having a master's, and they're saying we want to find the 95% confidence interval of all 30,000. So we know that 210 of our 250 have master's degrees, and they want to use that information to make a conclusion about all CEOs from all 30,000 companies. All right? So what do? We let our N equal 250. Our P hat is going to be 210 divided by 250, which is 0.84. The 95% confidence interval that we're looking for is the stat, which is our P hat, plus or minus the critical value. That's going to be a Z star looking at the infinity. And the standard deviation of our statistic is going to be that square root of 0.84 times 1 minus 0.84 divided by my N. So we have to go to our conditions first. It's an SRS, stated in the problem. Population must be at least 10 times the sample. So 250, population 30,000, we're good. N times P has to be greater than 10. We get 250 times 0.84, that's definitely greater than 10, 210 is greater than 10. N times 1 minus P has to be greater than 10. 25, or 250, that should be 250, times 0.16 is 40, and that's definitely greater than 10, so we know it's normal. Using the standard deviation formula, which is going to be the P, which is 0.84, or P hat, which is 0.84, times 0.16 divided by 250, we get 0.032. Again, this is one question that we've already gone over, but this is showing it. So here's the normal situation that we're talking about. The distribution is normal. 0.84 is our P hat value. 0.032 is our standard deviation we're going to use. 95% confidence interval, 0.84 plus or minus. This is your Z star score. This comes from 95% on the T table. Look, one line above, this is the infinity line at 95%. That's 1.960, and there's the standard deviation from my problem. I do this multiplication, and I get 0.04547, and it's 0.84 plus and minus that. So my 95% confidence interval is as low as 0.79453, all the way up to 0.88547. And then we make our conclusion. So this is the interval, that's the answer. The conclusions, we are 95% confident that the population proportion of the number of CEOs with master's degrees is in the interval 0.79453 to 0.88547. So the percent of CEOs having master's degrees will be someplace between 79.5% to 88.5% based on our sample. All right, so that's a quick version of how to calculate a confidence interval using sample proportions.